The topic at hand today that I want to cover, the next generation of reference management, or maybe evolutions in reference management. This ties to a scholarly kitchen op-ed that's going out in January. It's actually something I co-wrote with William Gunn. I'll just kind of drop that name. William Gunn was an early employee at Mendeley, and he had some really great insights on sort of the past, present, and future of reference management. And so I put forth a little bit of a perspective, and then I sent him some interview questions, and we went back and forth. And I think it'll be a really great piece. But this is almost a sort of a teaser, and in some cases more of a thorough review of the conclusions of that article. Obviously, it ties to the reference manager we just put out. Yet again, this is a case where we did a bunch of market research. We gathered a ton of great user information on issues with existing reference managers, and we thought that would be really great insights for this audience. And so I will talk a little bit about Mora in this presentation, but I'll try to be more general as well. What basically came first? This is not a complete history. There's all sorts of additional applications out there, but for all intents and purposes, EndNote really was the first major reference manager, certainly the first one that's still around and in use today. Launched by a company called Niles and Associates in 1989, specifically for Apple Macintosh. In 1995, they released a version for PC as well, and it was a kind of listed and announced as a dual-purpose software, which is interesting given what I'll get into in terms of the use cases of reference managers. But, quote, functions as both a database manager and as a bibliography maker to insert citations into word processing documents and compile the bibliography in the required format. So a couple things that were interesting to me is highlighting a use case beyond just kind of citations and references right off the bat. Again, we'll get into that. The other is, it's really interesting to me, the Microsoft Word integration and the text editor integration was there right at the beginning. I guess I would have assumed that would be something later on. APIs become more available. Websites can talk to each other more easily. That's something later. But right at the beginning, you had that Word integration. And it's something a lot of products still struggle with today, it seems. What then basically came next? Again, missing all sorts of applications here. But Zotero and Mendeley, obviously very popular today. But these were in the 2000s. I think the next big kind of these two companies or tools really led the charge in transforming reference management in the 2000s. The main organizing point probably was the introduction of the web browser extension. That was Zotero. With Mendeley, there were some other things like metadata improvements, and then sort of collaboration, social networking. What I thought was really interesting, and it speaks to, again, differences between even now, 20 years later, and 20 years ago when these tools were introduced. Zotero was initially sued by Thomson Reuters on the basis of them having allegedly reverse engineering EndNote's proprietary ENS style into what's now the CSL style. So the point is, Zotero's engineers, according to, I don't know, the lawsuit, not that I'm an expert on it, but Zotero's engineers reverse engineered the EndNote citation format so that users could migrate from EndNote to Zotero easily. And once again, why I found that very interesting was that today, Zotero and a lot of these tools offer publicly available APIs, make it very, very easy to connect into those tools. So that strikes me as a macro trend across, the internet. I think that's just really interesting, a lot more guarded back in the 2000s, 20 years ago. So the timeline here, 80s and 90s, let's call it the EndNote era. You had manual imports and local file management. You didn't have as much kind of software as a service functionality, didn't have as much connectivity. Most all of the metadata coming directly from publishers. As far as I could tell, you didn't have the aggregators. You certainly didn't have the organization specifically focused on maintaining metadata to then be queried as part of their APIs. And then indeed, that early tool did have cite while you write, as I mentioned. The 2000s and 2010s, 4 bullet points here. One is browser extensions. I think this is kind of in order of impact. I think that's probably was the biggest, let's call it upgrade, transformation. Metadata translators, so you could, import papers and citations from a lot of different sources. PDF processing. So it seems to me for the first time, people are actually doing some full text reviews within their reference manager, or at least storing full text files in the reference manager. And then again, namely with Mendeley, there was kind of a social networking element introduced. Now, a few of these areas I view as part of the story and yet still very immature, even 20 years later. The examples I'd provide would be metadata translator and social networking. When it comes to, say, collaboration on refuges, still pretty. I think a lot of that functionality is pretty immature. If you think of Zotero open libraries, for example, not tremendously searchable. It's definitely not a social network like situation. It's the libraries you work on, even if they're publicly available, mostly confined to the reviewers that you've added yourself. So then the question becomes 2020s and 2030s, three or four question marks. What is this era going to be characterized by? What I say in the op-ed piece and how I would sort of characterize this is that if John Frechette in 2040 listed these bullet points to try to describe the 2020s and 2030s, I would have three, and I'll try to pretty much explain all of them in depth, albeit a little bit sporadically via feature deep dives and whatnot. But the first one is definitely AI features, as you could probably guess. I mean, I think we are still, relative to, say, search, in reference management, we're still in the earliest stages of figuring out how AI models and LLMs are going to be integrated into all of this. But AI will definitely be, I think, the number one driver over the next, say, 15 years. Metadata enriching. So that is almost an extension of metadata translator, though, as I'll get into, given some of the vendor APIs available to us now, and again, these are intertwined, the AI models and APIs available to us, the ability to actually basically perfect your metadata and spend significant time getting your metadata more precise, enriching it, ensuring that your journals are complete, maybe even double checking, say, the year of a paper against multiple sources. Doing that automatically, I think, will be a big part of the 2020s, 2030s. And then finally, team workflows. Just set aside even social networking, more collaborative literature reviews. That's in reference management. That is, I hope, an extension of search. I hope that's in pretty much every area of academic research. So let me focus on a couple practical examples of this, and these are indeed, features that are either currently in Mora or that we're working on in Mora. And the first one that I find really, really interesting is, a lot of these features are pulled from other fields whose applications of AI are more mature, and now we bring them in. Here you have something called waterfalls. Waterfalls for metadata enrichments. This is indeed a way to sort of ensure your metadata is perfect. Of course, it won't ever be perfect, but whether you're working with seminal papers or gray literature, there should be a way to make sure that, for instance, your abstracts or summaries are fully populated. There should be a way to make sure the journal, or maybe in the case of gray literature, the organization that publishes a paper, is populated. And so we have in our tool what we call waterfalls. This is how we solve this. And so this is an illustrative example. Right now we focus on two of these in our product, but let's say you add a paper to your library from whatever source. Pretend you don't have much data on that paper other than maybe what you bring in from, say, search engine like Google Scholar. So you have author year, but you don't have abstract, you don't have maybe DOIs. The waterfall method is a way to grab DOIs, to grab abstracts, to grab all of that metadata. And specifically what we are doing in our tool is waterfalling through multiple vendors. So Crossref is the first one. We will almost always, when we grab the DOIs of a paper, we will check in Crossref to see if that DOI matches up with an abstract, to see if that DOI matches up with an ISSN, maybe some kind of citation method that we can import. If you don't find it in Crossref, our system is automatically jumping then to another tool. In this case, I'll use the example of OpenAlex, checking the DOI against OpenAlex, looking for abstracts, looking for the full text articles as well. That doesn't work. You fail over to Semantic Scholar. That doesn't work. The final, in the case of our tool, the final check is an AI model. And so, for instance, again, in the case of gray literature in particular, let's say you don't have DOIs and you don't have papers in Crossref, we are there for bringing in some Claude or say OpenAI agents that actually go out and find the information of an industry white paper, if that's what you've imported, so that you can populate that metadata. Again, it's not perfect. You do have to make sure as a software development team, you're rigorously training your models to make sure that, well, if the metadata doesn't exist online, it's just not there. Having said that, there is there is a significant amount of data we can populate with a Claude, with an OpenAI that you can't find in, say, a Crossref. So this is one way to perfect your metadata. It is very rigorous. However, it avoids having to do these things manually, and it also avoids having to just totally eliminate papers from your library because they don't have good metadata for citing and referencing those papers. So the broad kind of macro point there is that whereas I think most think of, kind of AI search engines, AI's biggest impact on academic research, reference management, thinking about summarizations. That is a great use case. So you've got 40 papers, how do you maybe put them all together in some kind of synthesis and summarize top methodologies, top findings, et cetera? That is a great use case. But in the case of reference management specifically, with researchers who are very knowledgeable in a particular area of literature, we have found that a lot of those summarizations and synthesis tools actually don't get you very far. Those are especially great for maybe new researchers getting into a new topic or something like that. For folks that are hardcore reference management users, I actually think maybe the biggest benefit we're talking about here is being much less dependent on publishers and aggregators having great metadata at the first line. So, regardless of not only having good metadata, say each publisher having amazing metadata, but also do they have the same formatted metadata? I think the answer is it kind of doesn't matter once you introduce these more advanced enrichments. Even if one, let's say, publisher labels a metadata field differently than another, we can reconcile those, and we can also go out and find that data ourselves if we need to. So just find that to be kind of an interesting take. That's what guides our development work. We focus less on 3-paragraph, 5-page summaries, much more on this kind of ground and pound stuff. Another deep dive here is the point about collaborative literature reviews. So just enabling more teamwork in reference management, in review workflows like screening. And in our case, what we're really focused on are features like this. These are examples, but being able to actually share open access libraries within research communities, that's something we're working on right now. We really want to make those searchable and very, very easy for folks to collaborate on, almost like a GitHub repository. So I think that is perhaps among the most powerful use cases. And by the way, the reason that's so powerful is particularly when you've got, an important, urgent, pressing topic. Let's say it's something coming out of the FDA or something like that. If you have a lot of collaborators, just like, when you work on open access software, you can get very, very good coverage in your library. Make sure you're not missing many papers when you have, so you sort of crowdsource the process of discovery, if you will. So that's one piece. Logging each user's added papers, notes, and activities. So just an activity log, I think, is important. And then assigning papers to users to be screened and annotated. Here, I think many disciplines can learn from the lessons and practices of systematic review users and researchers. And that is kind of my next point here. By the way, this is the team, myself, Ife, and Seth. This is how it shows up in Mora. If you add a collaborator to your review, it shows up like this. And then you might get an email that says, Ife invited you to build on her library entitled XYZ. So very, very simple to collaborate using Mora. The macro point here, once again, is that, and this is, we talk at conferences about this. It's sort of a hill that I'm willing to die on a little bit, which is that semi-systematic reviews. Okay, set aside the Cochrane guidelines, set aside the Prisma workflows, set aside the risk of bias assessments, something that looks and feels more like a systematic review, a semi-systematic review, which has, for example, formal search strategies and formal structured screening processes, should be far more prevalent across every discipline. The discipline I come from is economics. My feeling is that it's time to bring literature reviews in fields like economics into the realm of a formal, reproducible science. I mean, when push comes to shove, how most economics literature reviews happen are that the screening process is extremely judgmental and happens at the point of the search engine results. And so you more or less have folks that are, typing something in on Google Scholar or EconLit or another search engine and judgmentally selecting which ones look interesting. Very often there is no documented inclusion exclusion criteria or prioritization method. And it really is just like, hey, these 10, 15, 20 papers, yeah, that's cool. That's interesting. That abstract is easy to understand. Okay, that's my bibliography. That's my references list. And I feel like there's no reason that needs to be the case, particularly given every field's becoming more quantitative. I mean, with econometric studies, just about every economics question has a lot of econometric studies associated with it. We haven't really figured out the disciplined, structured literature review process that comes with all of that quantitative research. So again, I think that's very, very important. That's why sometimes we get confused for a systematic review tool. We do have systematic reviews, but our core tool is for narrative and kind of semi-systematic reviews. We think that's very important, and it lends itself well to teamwork. A few last slides here based on some data analysis. What we did is rip through a number of discussion forums, for instance, on Zotero's website, went through around 300 user tickets. Zotero has this amazing discussion forum where people are just constantly bringing up bugs, asking questions. And so we ripped through that and did some analytics and came up with really basic answers to really basic questions. One of the questions we had is, who are the predominant users? The other was, what are people actually using Zotero for? And then the third is, what are the top issues they deal with? In terms of the users, I didn't even include a slide because it's not, all that surprising. Predominantly academia, let's say 75 to 80% academia. You've got research professors, you've got a lot of research assistants, teaching assistants, interns, and then you have maybe 10, 20% librarians as well. So not much of a surprise there. In terms of what people actually use reference managers for, I think this is a question that doesn't get asked often. But again, maybe no surprise here. Citing and referencing papers is number one, obviously. But 50% of the users going onto Zotero, maybe more, are using Zotero for citing and referencing papers. Just kind of ground and pound in-text citations in Word, for example. Organizing your library and sort of file managing papers like a file explorer, that would be maybe around 15 to 20%. That's things like deduping, tagging papers, building collections. PDF capture and import, 15, 20%. Reading and annotation, an increasing number of users are using these tools for full text reviews, but it's still right around 10 to 15%. And then screening and review workflows still under 5%. What we call metadata enrichment and sort of updating your library with new information, I would say under 5%. That's a very low percentage. I would like to think it's sort of like a category that we're introducing. So I found that to be interesting. The top issues by extension, an analysis of 200, maybe 300 Zotero forum discussions. Many of them relate to really sort of technical citing and citation style issues. Things like, hey, this was supposed to be capitalized and it wasn't. Very, very technical stuff. My hope is that a lot of that actually can be not creation of citations, but then the iterating on them. Hey, you did this wrong, redo it with this. I think that will be something that AI will be very good at. By extension, Word, Google Docs integration, a lot of issues there. Just the connection breaking, for example. Capture and import, library and organization. I think the rest of these are fairly straightforward. The one thing maybe I'd call out is, indeed, I did notice a growing share of collaboration-related tickets. Things like, hey, can you add a field that tells me on the, say, Windows browser that tells me who added what paper to their library if there are multiple people working on a library. So that's that piece. The most cited, very specific issues. Again, Word couldn't communicate with Zotero. My guess is this is kind of the case across all the different major reference managers. Error updating documents, certain buttons not working. I think there are no big surprises here. But a persistent theme, not just in the kind of user forums and discussions, but in the actual industry perspectives, vendors putting out white papers on this, for example, the common theme is how to add value beyond just citing and referencing. I think there's an impression that that is something that's more of a commodity. So, how can reference managers go beyond that use case? Why shouldn't they be used, as I see here, to a greater extent for the workflow, for formal screening, for teamwork, for reading and annotation, for evidence synthesis? And of course, our answer is we think they can, and we think that it is the availability specifically of AI, but I might even, again, more specifically say availability of APIs that connect into the big general LLMs. We think that's what makes these workflow steps now possible in reference managers. And so I will call this broadly organizing citations into tables and enriching them with AI. You can see a very basic example here. You've got your title, your year, maybe that pre-populates from the whatever data source you're pulling that citation in from. But then you should be able to very quickly summarize study design and summarize findings. Now, what I use this for in my own research is sort of an on-the-fly evidence synthesis. However, the reality is there are tons of different ways in which people get value out of this. One is what to cite and when, okay? And so if you're actually just trying to decide, maybe you have a cluster of citations that accompany one finding in your publication. So you might not be doing full text reviews for those articles. So you cluster those citations and you can quickly see which ones support an argument or maybe support a contradicting argument that's in your publication. Definitely screening which articles to review in full is a big part of this. You might want to filter for, or say filter out papers that use survey data. Filter for papers that, in the case of economics, use econometric models. You don't want, theory-based papers or review-based papers. As I mentioned, for me, the number one use case is evidence synthesis on the fly and the ability to come up quickly with a narrative. This is where summarization comes into play as well. Coming up with it's my criticism often of literature reviews are it's just kind of a checkbox. Smith et al. 2020 says this, Marcus et al. 2015 says this. I think coming up with an overarching narrative and then plugging in each citation into that narrative is something that this is good at and that summarization indeed is helpful for. And then finally, just overall, I guess it ties to all this, but quickly comparing methods, findings, and other fields. So I do feel like tables are extremely powerful and just tables in themselves. And I think that is in part how we get from citing and referencing to actual literature review workflow steps, more downstream in the process, if you will. So the concluding summary here, each period of reference management is driven by underlying technological developments like web browser extensions. 20s and 30s, I think, will be focused on AI, metadata cleaning, and teamwork. Impacts of AI, again, everyone focuses on summarization. Everyone also focuses on search. Ability to get unbelievable metadata, clean metadata, I think is really a powerful use case. Collaborative semi-systematic reviews will, or at least should, be the new normal across all fields, particularly when you're not just doing scoping, you're doing a serious literature review. And then beyond citations and references, getting papers and citations into tables and coming up with some AI generated metadata fields to analyze them and compare them and do evidence synthesis. I think that's what will allow these tools to, as I might describe it, vertically integrate further, get more involved in different aspects of the research process. Bringing this all back to Mora, I actually don't have this set up. Here's the Crowdcast right here, but let me go ahead to the tool. And I think I showcased this last week, but what I'll just say is that every feature I mentioned is covered right here in Mora. So if I'm going to go to search, I'll use an example we always use, which is effects of exchange rates on trade. It's a really maybe boring example, but that's produces some great kind of papers. So if I'm to save down, say, 3 or 4 or 5 of these papers from Google Scholar, note that if it's Google Scholar or it's a PDF, we don't actually have those DOIs. We don't get DOIs in that metadata like we do from a PubMed citation import. So instead, we go through a process of enrichment on our end. You'll notice here we did get one DOI. However, 4 of them need to be, quote, enriched. And so what we do is click fix. And now we have an algorithm, much of it based on AI, that goes out and finds the remaining DOIs. And we are rigorously testing those to make sure that they are not making DOIs up, not hallucinating. And particularly with Google Scholar, we've got about a 100% hit rate, albeit occasionally we get a working paper without a DOI, and so it says no DOI found. From here, though, we have, for instance, an unknown journal. Let me just show you how this works, how you can clean up your metadata on the go. You have an unknown journal. Let's go into journal. You can see the waterfall, which is Crossref Semantic Scholar at the moment. I'm going to rerun all papers. And as we'll see right here, the journal that just showed not found now shows up as an SSRN working paper. So this is a very clear demonstration for how you can use a combination of vendor APIs and AI fields to clean up your data, make it perfect. So you could do the same with authors, citations, and of course you could add fields as well, adding fields such as, main findings. I had mentioned that before. Main findings is where I can go in, and sometimes we won't have all the data, but main findings is where we can go in and get the quick AI fields, the summaries. So not mentioned, in some cases you'll get, it's key not to hallucinate. But again, now what you can do is actually go in and rerun the abstract as an enrichment, and then the AI field will pick up the updated abstract that got caught in the waterfall. So it is a process. It's a little bit involved, but here's, again, a really, really cool way to manage this. So that is the key demo. Lastly, I'll just say thank you very much for joining. Upcoming sessions, we've got the biggest retraction stories of 2025. I do want to do a full session on systematic reviews, namely for folks that aren't in health sciences and other fields that can learn from that. And then it is about time we do a thorough review of AI teaching policies. I just finished up my semester, and every time you go through grading final papers and grading any sort of writing assignments, it's certainly in the back of my mind thinking, what we should really do is get out there and, through a combination of academic papers and actual publicly available university policies, let's do a massive review and consolidation of what's out there. What are the key fields covered? How are people tackling this? And what is the recommended best strategy? There's a lot of disparate ideas here. If you have any questions, reach out to me, john@mora.io. Really appreciate everyone joining, and I'll see you next week. Hope you have a great weekend. Thank you.